Okay, and so now to finish off section 2.6, we'll look at log rules. And this is problems 43 through 66 in the book, and plus some of the word problems about doubling time and stuff like that. So there are 3 log rules about how logarithms interact with each other. The first is log base b of a product, x times y. You can break that apart into a sum. And one thing to note about mathematics, right, is that mathematics is a little different from language. In the English language, you only read left to right. So you'd say log base b of x times y equals, or can be broken up into a sum, log base b of x plus log base b of y. But remember that math can be read both ways. So you can also read this from right to left, which if I rewrite it is this. If I have 2 logarithms added together with the same base, if they're added together, I can bring it together into one logarithm multiplied together. So that's one of the log rules. Second one, if you have a division inside of a logarithm, you can break it apart into a subtraction, log of the top minus log of the bottom. And of course you can always read it the other way. If you have a subtraction of 2 logarithms, you can bring them together as a division inside of a logarithm. And the third, and this is the most important one for us, is if I have an exponent r, x to the r, inside of a logarithm, the r can come out front as a coefficient. And vice versa, of course. If I have a coefficient of a logarithm, a number times some logarithm, I can put log base b of x, the coefficient inside the logarithm, as a power. Okay, so those are my 3 log rules. And remember that an equal sign means you can read it left to right or right to left. So this rule at the top here can be either read as breaking apart a product inside a logarithm or pulling together 2 logarithms that are added together. Okay, so some problems along these lines. Solve log base b of x equals to 3/2 log base b of 16 plus log base b of 2 minus 1/2 log base b of 64. So what is x? Well, the goal here is to take all this stuff and pull it together using our log rules into one logarithm. Right? So if I can rewrite all this as log base b of something or other, then whatever this is, whatever I end up with, that's got to be equal to my x. So what's the first thing to do in solving these? Well, we'll use the third log rule here to take all these coefficients and put them inside of the logarithms. So log base b of 16 to the 3/2. This 3/2 goes inside the logarithm as a power, plus, well, there's no coefficient here, so we'll just leave that as a 2. And then this minus 1/2 goes inside, well, the 1/2 goes inside of the logarithm as a power. Okay, and now we can simplify these things a little bit. What's 16 to the 3/2? Well, that's 16 to the 1/2 cubed. So that's, well, square root of 16 is 4 cubed, so that's 64. And 64 to the 1/2, well, remember that 1/2 is square root, so that's 8. So great. What we got now, by cleaning out the coefficients, is log base b of 64 plus log base b of 2 minus log base b of 8 because the 64 and 1/2 is 8. And now we can use the first two log rules. Addition of two logs can pull together into multiplication. So log base b of x is log base b of, I can take these two that are added together, just multiply the 64 times 2. And I'm not actually going to multiply that out because you'll see in a minute. And then minus log base b of 8. Great, now I've got a log minus another log. Our second division logarithm rule says if I have log minus another log, I can turn that together into a division. And so finally we get getting log base b of x is equal to log base b of this part, the 64 times 2, well, it's log base b of this minus log base b of that, so this becomes the numerator, this becomes the denominator inside of my logarithm. And so now, as you do these, you can go from something that looks like this to this pretty quickly, right? Once you've cleared out all the coefficients, then when things are separated by a plus sign, you multiply, and when there's a minus sign, you divide. So 64 times 2 divided by 8. 64. Right? And if you do that, right, 64 divided by 8 is 8 times 2. That gives you 16. So now we have log base b of x equals log base b of 16. So x is equal to 16. Right. So in given these sorts of things, deal with the coefficients first, bring them inside as powers, and then use the rules about addition and subtraction, turning it into multiplication and division, to pull it together as one big logarithm, and then you can say, okay, well, it's log base b of x is log base b of 16, so x has to be 16. Sometimes you get some issues involved. Suppose we want to solve log base b of x plus log base b of x minus 1 equals log base b of 6. Right, so same goal. There's no coefficients to worry about. It's an addition here, addition. So this times this, x times x minus 1 equals log base b of 6. So if things inside the logarithms must be equal to each other, if their logarithms are equal to each other, x times x minus 1 equals 6, x squared minus x. Bring the 6 over to the other side, minus 6 equals 0. Why do I want to bring the 6 over to the other side? Well, it's a quadratic, and whenever we're solving a quadratic equation, we usually want it equal to 0. This one actually factors, right? Minus 6 is minus 3 times 2, plus 2. So what's x? X is 3, or x is minus 2. Those are your two possible solutions. But remember, domain of logarithms is x greater than 0, right? And so if I tried to plug this solution, x equals minus 2, this supposed solution, back into the original problem, what would you get? You get log of minus 2 plus log of minus 3. Well, you can't do that, right? Because you can't put in a negative number into a logarithm. So x equals minus 2 is not a solution. So you can't use it. So our only solution here is x equals 3. So one thing you have to be careful about, a little bit careful about when you're dealing with logarithms, is making sure that your answers, when you plug them back in, actually work. If you get negative answers, sometimes they won't. So another problem along the same lines, suppose log of x plus log of x minus 1, set up the same kind of way, equals 2. Well, that's a little bit of a problem, right? Because we don't know what the 2 is, right? If we can bring this together as log of x times x minus 1, but that equals 2, but we don't know, we need to have this as log of something. So let's note, if there's no subscript, right, that's base 10. So log base 10 of what equals 2? Well, 10 squared. Right? Because if you have log base 10 of 10 to the second, what power do you raise 10 to get 10 to the second? That's 2. So log base 10 of 100 equals 2. And so that allows us to plug this back in and say, okay, well, log of x minus 1 equals log of 100, because 2 is equal to log of 100. And now we're okay. X times x minus 1 equals 100, right? We can get rid of the logs, and we can solve this. X squared minus x minus 100 equals 0. This doesn't factor in any particularly nice way. So you can just solve it by using the quadratic equation. X equals negative b, so that'll be 1, because b is negative 1 here, plus or minus b squared, which is 1, because minus 1 squared is 1, minus 4ac. So 4 times a is 4, times minus 100 would actually give you plus 400 all over 2. So x equals 1 plus or minus square root of 401 over 2, 1 half plus square root of 401 over 2, and 1 half minus square root of 401 over 2. This one is less than 0. That one's greater than 0. So this is not a solution, because you cannot put a negative number into a logarithm. And if this is the solution, if you tried plugging that number back into the original equation, right, you get a negative number in here. Okay, and so that's most of the log problems. One last log problem is about investment. So suppose you invest, this is one of these word problems, $1,000 at 4% interest, compounded daily. Right? How long will it take to get to 2,000? With this account to get to $2,000, right? And so what we're actually looking for here is the doubling time. How long does it take your money to double? Okay, well, the formula, which you ought to memorize, is that. There's our compound interest formula. A, P, R, M, and T. So the amount you want in the future is $2,000. The amount you're investing is $1,000. The interest rate you're getting is 0.04. Remember, percentages have to be turned into decimals. The number of times you're compounding a year, well, if you're compounding daily, that's 365. And we don't know what the time is. How long does that take? So plug everything in. 2,000 equals 1,000 times 1 plus 0.04 over 365 to the 365 times t. And there's our unknown. It's the time. It's up in the exponent. We need to get it down out of the exponent to be able to solve for this. So first thing to do is divide both sides by 1,000. Right? So 1,000 here, 1,000 there. These cancel. This becomes a 2. And I'll multiply this thing out. 1 plus 0.04 over 365. It is some horrible number. 1.00010959. At least that's what Microsoft Excel tells me. 365t. Okay, and so now we need to be able to solve for t, which means getting the t out of there. And so remember, or recall, one of our log rules, in fact a very useful one, log of, here I'll just use ln actually, ln of A to the B is B ln of A. I can take a power and pull it out front if I take the logarithm of it. So this is an equation. If you're going to take a logarithm of one side to get this power out, you got to take the logarithm of both sides. So we take the logarithm of both sides. Natural logarithm of 2 is natural logarithm of 1.000109589 raised to the 365t. So all this is inside of the logarithm. And now since I can use this log rule, this power can come out front as a coefficient. So natural logarithm of 2 is 365 times t times the natural logarithm of 1.000109589. Excellent. Log of 2, that's just some number. Log of this horrible number, also just some number. 365, also just some number. So we'll just divide to get the t all by itself. We'll divide both sides by 365 times whatever this is. So log of 2 over 365, and it's a 5, not an 8, times logarithm of 1.000109589. That is my time. Great. Then if you grind this through your calculator, or as I did it on Microsoft Excel, this is 17.33. Now a little squiggle over an equals sign means roughly, right? So it's about 17.33 because you had to round because of all the decimals floating around. So 0.33 is about a third, so 17 years, third of a year, that's 4 months. And so there's the doubling time. At 4%, calculated daily, it'd take about 17 years and 4 months for your money to double. And we'll go into that in a little bit more detail later, and also I'll post up a separate video, sort of a bonus video, that for those of you who want